Assalamualaikum and greetings to Dr. Amzari. My name is SYAZANA binti Hamid and matrix number is 207071. So I am the representative of group 6. We will begin the presentation of differential equation in academic disciplines. So I'll start with the introduction. So differential equation is a mathematical equation for an unknown function of one or several variables that relates the value of function itself to its derivatives of various orders. There are various applications and principles of differential equation that are broadly used in all major scientific, such as physics, chemistry, biology, or engineering fields. The application and principle of differential equations genuinely play an important role in a variety of disciplines. The insight which is gained by solving the differential equation leads to a more complete understanding of the process, such as physical processes that are being studied. Differential equations are really the foundation of understanding many of the most important processes and phenomena in the nature.
Assalamualaikum and hi, my name is MARYAM AQIELA binti ABDULLAH. My matrix number is 206646 and I will present the aims and objectives of this report. There are 4 objectives to be achieved in this report, which is the first one is to show the principle and applications of differential equation in different kind of field. Second one, to relate the differential equations in determine the rate of population growth. The third one is to relate the differential equation in determine the rate of falling object, and the last one is to relate the differential equation in determine the takeoff run of an aircraft. The first principle and application of the differential equation is in biology field, which is the population growth. The standard form of equation of general population models can be written as rate of change is equal to number of births minus number of deaths. Let Pt represent the population of the species of interest present at that time t. Thus, by differentiate this equation, we can obtain P apostrophe t is equal to changes due to births minus changes due to deaths, or is also equivalent with P apostrophe t is equal to Bpt minus dpt. Or by factorize the pt, we also can write this equation into this, which is P apostrophe t is equal to B minus d times pt. Note that B represent the rate of births and D represent the rate of deaths, and the variable of B and D could be either the function of time or may be related to the population, depends on the environment conditions and particular species. Assume that both variables B and D are constant, hence equation 3.1.4 can be simplified as P apostrophe t is equal to x pt, where the variable of x is constant and x equal to b minus t. From equation 3.1.5, the variable of x can be either positive or negative value depending on which the value of b and d of that particular population are dominant at any given population level. The population is said to be increasing when x is positive and the population is decreasing when x is negative. So, x can be called as the rate of growth of the population or rate of decrease of the populations. The changes of P is mathematically directly proportional to the size of the population present, and it's present as an exponential growth population. Let T0, Y0 is an element of AB times CD and assume F is continuous on AB times CD, and Y is the solution of the initial value problem on an interval of I subset of AB that provide T0 is an element of I, and YT is a solution of the initial value problem on I. Thus, this statement can be simplified as Y0 is equal to Ft, Y and Y T0 is equal to Y0. From that, the differential equation 3.1.5 is easily solved as a first order of differential equation driven to general solution P in terms of T is equal to P naught times E to the power of RT, where P naught is the initial population size. Thus, it's important to note that this population model is not relevant in our real life. This is because due to several factors like environmental issue, weather, food and disease, and illegal hunting, so exponential growth is not realistic.
So I will continue with the second application in physics field, which is free-falling body. So the free-falling body, the name itself, we can consider and imagine an object experience a free-falling motion. So when the object experiences the free-falling motion, the body would move down because of its own weight or gravitational force. In this case, the object weight will be the gravitational force. So now consider an air-resistant force counteracting the free fall. Counteracting means it opposite, as you can see on the screen, it opposite the W opposite the air-resistant force. So there are many ways to assume it drag, but for now, the air-resistant force is proportional to the velocity. So without further ado, we can continue with the calculation to understand better. So we will start with the calculation of free-falling bodies. So first, we're gonna draw first the free-falling bodies. So this is the gravity force, while this is the air-resistant force. So we know that this gravity force equals to the weight, as mentioned before. G equals to m mass times gravity, and the air resistant force is the proportionality of it is air resistant force is proportional to velocity. We have mentioned in the previous slide. So we convert the proportionality into the equation, and it will become Ff equals to k velocity. K is the constant that is the proportional constant, which is dependent on the problem. Okay, so next we move forward by applying. We're going to apply the Newton's second law, which we will look along the forces, the summation of forces along y-axis, because this falling object is only consumed only on the y-axis. So we're going to apply the Newton's second law, which is summation of F forces along the y-axis equals to mass times by acceleration. So this is the Newton's second law that we will apply in the partial differential equation. So the forces along y direction is gravity force minus by the air resistant force. So why minus? Why minus? Because because the forces that are of the same direction as of the object's movement is positive. So we see the movement of the object is falling right, so we're gonna take it as the positive side, and the the opposite side will be the negative. So continue with the equation. Fg minus Ff equals to mass times acceleration. So we know above Fg equals to mg and Ff equals to kV. We just substitute the equation, the formula, into the equation. So mass times gravity minus constant K, V equals to ma. So in these steps, we're gonna take the acceleration as instantaneous acceleration. So we just substitute the A equals to dv dt, dv dt into the equation. So we will get mg equals to kv minus kv equals to m. We substitute the acceleration into the equation, instantaneous acceleration. Okay, m dv over dt. Okay, we have arrived in this not so final step, so we will move forward to finish the equation of partial differential. Differential equation. So we have done mg minus kv, right? So we will rearrange the formula. We will rearrange the equation to have the differential equation of free falling body. So how to rearrange it? We will have dv dt is dv, we will have dv over dt plus kv equals to mg. Okay, we rearrange it, and then we will left g alone in the right side. So we will have dv over dt. Okay, before we have m dv dt, right? So here I forgot to rewrite. So dv dt plus k over m times v equals to g, because we have cancel the m and we got the m in this below the key. So this is the final differential equation for falling body. Okay, dv over dt plus k over m times g times v equals to g. Thank you.
For the third application is aircraft take-off run from aviation field. The differential equation will also consist in determining or predict the length of runway so that the aircraft be able to take off safely. First of all, we must determine the force acting on the plane during the plane still on the ground before calculate. As we can see at the picture, I have already determined the force that's exerted on the plane, and that force is lift force, thrust, weight of the aircraft, friction force, drag force, and reaction force at the wheel. Okay, first we need to determine the total force acting on the x and y axis. So here the y and x axis of the force. Second, from this research, I found that there are experiment evidence which is assume that the lift force proportional to velocity squared, the drag force proportional to velocity squared, and reaction force of the ground friction force proportional to reaction force of ground normal force. Ground force, also known as reaction force at the wheel, at vertical. Third, into the equation of y-axis into the equation of x-axis. Fourth, put the assumption of L and D into equation number 3. So it shows that to find the distance that the aircraft travel along the runway, it used first and second order of derivative. 5, we need to determine the T. Is it constant or not? Whether the pilot open or close the throttle during the takeoff run. Also, we need to determine the other constant, which are m, mu, alpha, and beta. So once the equation is complete, it can be used to calculate the length of the runway. So the conclusion we get is we learn about differential and multiple of its application. It's clear that differential equation provide significant advantages for various fields, including the fields mentioned above as well as the field not mentioned, such as art and the music. It is important to understand all the concept of differential equation in order to solve all the problems in real life, such as growth of disease in medical terms and gross domestic product (GDP) in academic terms to determine the economic health of a country. However, as a knowledge seeker, we should make a good use of differential equation as long as the equation is relevant to be used. So that's all from our group. Thank you.